Hello, everybody. Tonight we are going to talk about inductive reasoning. So, inductive reasoning is the process of observing data and recognizing patterns and making generalizations about those patterns. Okay, so an example of that would be a scientist dips a platinum wire into a solution containing salt, excuse me, otherwise known as sodium chloride, and then takes that wire and puts it over a flame and observed that it produces an orange-yellow flame. So now he takes a platinum wire and he keeps dipping it in other solutions that contain salt. And he finds that every one of them produces an orange-yellow flame. So make a conjecture based on his findings. Well, that conjecture would be, if I burn a solution with sodium chloride, it will produce an orange-yellow flame. Now, does every conjecture come out to be true? No. But a lot of times they do. Okay. Here's one that you might have found out when you were a little kid. I go to Grandma's house and she gives me a cookie. Then I go to Grandma's house another time and she gives me a cookie. And I go to Grandma's a third time and again I get a cookie. What do I learn? I learned that if I go to Grandma's house, I'm going to get a cookie. And when you're a parent, you'll find out that time that you go to Grandma's house and your kid doesn't get a cookie is not a fun time. Okay, so moving right along. I can use inductive reasoning to find patterns in different kinds of things. For example, if I look at this sequence, 2, 4, 7, 11, okay, I want to figure out the next three terms in the sequence. What's the pattern? Okay, so why don't you take a look at this, use a little inductive reasoning and see if you can figure it out, and then pause the video while you do that and then see if you got it right. Okay, here's what I noticed on this. That the difference between those two is 2, and the difference between those two is 3, and the difference between those two is 4. And so I'm guessing that the next two, the difference is going to be 5, which would make this 16. And then the next one, the difference would be 6, which would make this 22. And the next one, this would be 7, which would make this 29. Okay, so I used inductive reasoning to determine what this is going to be. Now, that was a pretty easy one. All right, this has an easy part and a difficult part. So the first part of this, if I start with this figure and I go to this figure, and then I go to this figure, and then I go to this figure, and then I go to this figure, what is going to be the next figure? That's a tough one. So let's take a look. Each time I add a side here, I had 3 sides. I had 1 side. Then I jumped to 3, because you can't really do 2. Then I went to 4, then I went to 5. So the next one I'm going to guess is 6. Kind of 6 like that. Okay, and then it has all the diagonals drawn. So I'm going to go ahead and draw the diagonals. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh. Did I do that right? 11. I feel like I'm missing one. Oh, I'm missing one right here. There's 12. see, I got 4, I got 4, I got 3. Did I get them all? I think I got them all. Nope. I'm missing this one. 3, 4, 5, 6. Oh, no wonder I got too many sides. All right, let's try it again. I knew that answer wasn't supposed to be that big. Okay, so let's try it again. I got 1, 2, 3, 4, 5, 6. Okay, now let's draw some diagonals, okay? So I've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, that's all my diagonals. Okay, so next, that's the easy part. I got my pattern figured out there for that next one. Now, find the pattern in the number of diagonals for each polygon above. Okay, so I'm going to ignore these two because they're not polygons. So this one, I'm going to go ahead and make myself a little chart here. We'll have number of sides, and then we'll have number of diagonals. Okay, so I can make myself a little table here, and I had 3 sides. I had no diagonals. Then I had 4 sides, and I had 1, 2 diagonals. Then I had 5 sides, and I had 1, 2, 3, 4, 5 diagonals. And then I had 6 sides, and I had 9 diagonals. Okay. So, can I find a pattern? Well, there's kind of an easy pattern and a difficult pattern. Easy way to do this would be to say, well, that goes up by 2. That goes up by 3. That one goes up by 4. So the next one, if it had 7 sides, would have 5 more. So that's going to be 14. Okay. And then the next one, if I had 8 sides, would go up by 6, and I would have 20 diagonals. Okay. So I can kind of see a pattern. The pattern I can explain is, hey, the number of diagonals goes up by 1 each time. Okay, now, there is a formula. Now, that's a lot more difficult to figure out. You can get n times n minus 3 divided by 2. Will tell you how many diagonals it has. Okay, so in this case, I would put n as 3. All right, so I put in 3 and 3, and that'd be 3 times 0 divided by 2 would be 0. If I put in 4, that'd be 4 times 4 minus 3, that'd be 1. So it'd be 4 divided by 2 would be 2. If I put in 5, that'd be 5 times 2 would be 10. Divided by 2 would be 5 again, and so on. So this is a pattern, and that you can find that'll tell you the number of diagonals. And if you can come up with how that's done exactly, you might find yourself some bonus points. Okay. Now let's talk about deductive reasoning, because that's a whole different thing. Deductive reasoning is the process of showing that certain statements follow logically from agreed upon assumptions and proven facts. Okay, so, for example, in each diagram, the ray AC bisects an obtuse angle BAD. So I have angle BAD here, I have angle BAD here, I have angle BAD here. Each one has the ray AC that bisects it. So if it bisects it, that means it cuts it into 2 equal parts. Okay? So those are equal, and those are equal. Okay. So classify angle BAD and angle DAC and angle CAB as acute, right, or obtuse. Okay, so BAD is obtuse in all of these. These 2 angles are acute in all of those. Okay, so what's a conjecture I can make? My conjecture is, if an obtuse angle is bisected, then the 2 newly formed congruent angles are acute. Okay, and you can actually prove that because you can say, well, if it's obtuse, it's at most 180 degrees. It's got to be a little. It's got to be less than that. And so if I divide that in two, that means that the two angles have to be less than 90 degrees, which implies that those are acute angles. Okay? Okay. So here I got a little assignment for you. Have fun with that. I will see you guys a little later. Bye.